Most inlines have a neutral position switch that closes and creates a path to ground whenever the engine is in neutral. The EMM uses this information to prevent over-revving in neutral. On tiller models, this switch provides start-in-gear protection. If the outboard is in gear, the EMM will not activate the injectors or the ignition system. There is no mechanical interlock to prevent pulling the rope when the engine is in gear. On 2009 and older tiller models with electric start, the starter motor will still crank the engine when it is in gear, but the EMM will not inject fuel or provide spark. Remember, if a customer has trouble starting a tiller model, make sure the outboard is in neutral. The EMM will store code 19 when somebody attempts to start it in gear. This code will not illuminate the LEDs on the EMM. On 2010 and newer 40 through 90 models, the neutral position switch controls the ground for the starter solenoid. This prevents the starter from operating when the engine is in gear. A kit is available to install a tiller on V4 models. This kit includes a neutral position switch. If a tiller handle conversion kit is installed on any model, use the diagnostic software to change the neutral switch configuration to the tiller setting. If you ever convert a 2004 through 2010 tiller model to remote control and it has a serial number below 5261353, leave the neutral switch configuration on the tiller setting. This prevents the engine from being rope-started in gear. For more information, refer to Warranty Bulletin 2009-02W. A PDF of this bulletin is included on this DVD. 2010 and older 90-degree V models have a shift interrupt circuit to ease shifting out of gear. It's activated by a shift load switch on the shift lever. When the switch closes, the EMM interrupts fuel on the port side cylinders. In 2011, this switch was replaced with a neutral position switch. The EMM uses input from this switch for start-in-gear protection and to limit engine speed in neutral to approximately 1100 RPM. Inline models use an onboard oil tank under the motor cover. From 2004 through 2007, the tank contains two sensors. A switch monitors pressure pulses from the oil injector pump. This switch will be discussed in Module 4. There's also a float switch to activate the low oil level warning light on the system check gauge. The low oil sensor is not monitored by the EMM on these models. Beginning in 2008, the pressure switch was eliminated and a new strategy was employed. We'll examine this in Module 4. V models have a water-in fuel sensor located in the spin-on water-separating fuel filter. If it detects water, it turns on the check engine light and stores code 37. This filter and sensor are standard on all 90-degree models and 2009 and newer 60-degree models. A kit is available to retrofit 60-degree models from 2007 and 8. Starting in 2010, 90-degree V models feature a knock sensor in each cylinder head. Some late 2009 models also have this feature. These sensors enable the EMM to protect the engine from being damaged by detonation, often called knock. Common causes of knock include overheating and poor quality fuel. If knock is detected, the EMM uses the input from the CPS to determine which cylinder experienced the knock and makes adjustments to that cylinder only. The EMM can reduce spark advance and/or add fuel to eliminate the knock. If the knock persists, the EMM activates safe and sets a code. Fault codes 1 through 6 indicate excessive knock has been detected. The code number indicates the affected cylinder. Fault code 7 indicates the port knock sensor circuit is open. Fault code 8 indicates the same for the starboard sensor. Check the sensor connection. To troubleshoot fault codes 1 through 6, make sure the sensor is securely fastened to the cylinder head. Make sure the timing pointer is accurate and use the diagnostic software to confirm the timing, following the procedure in the service manual. Test the fuel and cooling systems. Try running the outboard on fuel you know is good. Knock can also be caused by running the engine out of fuel or by running a propeller that doesn't allow the engine to reach its operating range. Other factors, like loose objects in the boat, can create vibrations that trick the EMM into setting these fault codes. Look for loose jack plate, engine mounting, or steering system hardware. Check the condition of the propeller and look for loose propeller hardware. Make sure boat accessories, such as power poles, are installed properly. Look for RFI generating electronics, such as side-scanning sonar. Vibrations can also result from exceeding the engine's maximum rated RPM.